Hello, good afternoon. Happy New Year, everyone. It's been a long time since I posted some videos. Long time no see. I hope everyone is safe and well. Been a while since I posted a video, probably about a month or so. I can't remember when was the last video I posted. And mostly was about the V5 SMT Pro pick and place machine. It's a great machine. In this video, I'm not going to talk about that machine much. I just wanted to quickly highlight to say to the V5 SMT Pro team, thank you so much for the updates. Really had no time to play with the machine. I'm very sorry I had no time to make more videos. Been really busy with my life, family stuff, and also looking at my father, who lives now with me, and also on the job I had to do to actually support my father. So there's a lot going on there, so that's why I slowed down for the past year, but trying really to pick myself up, trying to really pick things up, see where things come from there. Anyway, so in this video, or let's just go back and take a little bit step back. In 2025, you saw a lot of things happening, a lot of things being purchased, a lot of things being planned, the V5 itself, the laser machines, all sorts of bits and pieces were purchased just to kind of get that product done, or at least started somewhere. So now, in this year, hopefully, I am fingers crossed, we're going to start seeing production. So production of the motherboards, production of the new open source stuff that I'm actually working on. And there's a lot going on there. But it's one of those things where I would say the worst nightmare for someone like me who doing YouTube videos is the thinking of, is it good enough? Yes, I want to make some videos, I want to do some stuff, but is it going to be good enough? And I keep getting to that stage where no, it's not that yet, it's not there yet, no, it's this is still not working, etc., etc. And I end up eventually doing too much and not producing a single video. And that's why one of the things actually taking me some time. So what I'm going to do in this video is go back, take a step back, back into my board, which is the the Omap board that I actually developed and designed. And this is why I bought the PMP machine at some point. So I want to get the PMP machine to place this and complete the work on that board. But the problem is I need to get the board to a state where I'm actually personally happy about it. So in this video now, we will start, we'll do some bug fixing to get this whole thing up and running and kind of, in a much better state that what actually we had before. And also just to touch on what's coming up in the 2025-2026 year. Many people have been asking me about the Kronos and what's going to happen to it, etc., etc. So even though I'm not Korg, but I will get back to it soon, I would say, within the next 2 quarters of this year. In particular, people asking me how to move the motherboard from the existing D510 into something else, and I've done it a million times, and I'm happy to do that online and share and how to get people to move this into a different architecture or different system altogether. After 6 months, we are probably looking at maybe a 64-bit if we have time, or go back into my own map and then progress it this way, because I'm actually more into making my own OMAP instrument than to twiggle and tweak stuff that's 10, 15 years old. So yeah, I mean, but the Kronos is there. It's there just to do development and things like that. I don't really play with it at all. I've not played with it for years and years. I like Yamaha, and for Yamaha users also 2026, sorry again, not had a time to play much, but we will do something, I promise you. It's just I have been absolutely up to my head. So anyway, let's stop talking and then take some action. So now we're into working on this board. So the board basically I'll just explain what's happening there. Take the USB. So this is basically here the USB. You got 5 USB ports in there, and when you power this up like that, you get this light, and you think you see there's actually something, you know, there's life in there at some point. So the board is powering up, everything is going okay, but most of the stuff are not up yet, and we don't know what's happening. You just, you know, seeing just the light doesn't mean it's all working fine. There's a lot of things in the background that we need to kind of iron out. So you've got the Omap board in here, the CPU here, you've got the flash memory, and you've got the MMC, so the SD, MMC, the memory card, or the memory chip in there, to kind of obviously act as a RAM for the system. So now when we power things up, we will get some. Let's just take that down and then carry on this way. So if I go here, right click, and then device manager. So now what we're going to do, we're going to start working on the bug fixing of the Omap board that I developed. And it is a known thing to have some bugs in your design. So in here we're going to look at, so now I have the board kind of sitting down there with the power coming in, and on the ports we have only serial port 3, which is nothing. So if I disconnect there, that's nothing to do with that port. So reconnect again, and now we have nothing. So first things first, is the board working or not? So let's just kind of touch on that. So what we need to do to explain on the USB ports in here. So this port in here is used for power, and that's the power port next to the, you know, the 5 volt. Sorry, let's just take that down. So the 5 volt DC is actually sitting here. This USB is also to give just power, and when you power this up, the Omap will sense there's a VV-USB signal coming in, and actually will start to talk to this one. If you have code on the USB on the Omap side, it will talk to the USB as needed, as for development. So that's one thing. The other bit is you got the second and the third. So the second one here, the second USB, is for the serial communication on the Omap board. So the serial goes to this chip in here, which is the FTDI, and the FTDI is connected directly to the UART2 port on the Omap. So that when you connect anything in here like that, right? Let me just take a screen for my screen capture, and take it with me. That's it. That's fine. And yeah, so that's good. So when I do that, so if I connect this board to this port in here, you can now see a new device coming up, and there should be a new port coming up here at some point, and nearly there. There we go. So now we have COM 13. So that's the COM port that's actually working fine. And the next one is another COM port, which is sitting down here. So that's another FTDI chip down there. You can see that right away. So the FTDI 1, FTDI 2, which connected to this one. So disconnect that one, reconnect it there, here. And there should be another port coming up. So you can see the ports are actually listing up. They're not being detected before, and these are the first time being detected. So you can see that's actually is a live demo. It's not something we're making it up. So that's the second port. So that's the port for the second one. This one is an additional FTDI port, and you can see the header pin in here. So that is in case you want to do another serial, like serial 1 or UART, whatever it is, or you connect it to another device, or you have something completely outside this board altogether. You use that to that, and that's a USB to serial connection. So that's all done for you as well, and that serial works fine. So the third one is the ESP32. But when we plug it in, when we plug in the port, and you can see the lights coming up, you get nothing on the COM port. The reason for that is because these devices, so apart from the Omap, the RAM, and the flash memory, the USBs will not power anything up otherwise. So to power this one up, you can see there's a little pin, a little jumper in here. So the jumper in here is to power that one up. So if I just disconnect that one now and get a jumper in here. So let's take one of the jumpers from that one. So if I do the jumper in here like that, see that there? Now it's plugged in. Now if I connect that one here, I should get, now you can hear that thingy going off, and we have a USB COM15. So now that's COM15, very nicely done. And if I disconnect that one down here, I reconnect it to the last one, and this is the JTAG port of the ESP32. So in an ESP you have a JTAG and you have a serial. So the serial is, so you can see nothing happened in here. So when I reconnect that one back, I don't get any notification, even though this is going straight to the FTDI chip. There's no power on and off of that one, but there's nothing happening. And I did debug this before, and I'll walk you through that in a minute. So that's one of the first bug fixing we're doing at the moment. So, or the second one. So now, connecting back to the ESP32. So this is now on ESP32, and now we are COM15. So if I just go into here and click on Arduino, where is Arduino gone? Here we go. So if I go to Arduino, and I'm going to use COM15. There we go. Okay, so we have a test thing going on. So the test basically is very simple. We switch on the port at the speed. We also log some stuff to the second serial port, and it's just basically a loop that says, you know, here I am, and then it will keep displaying dot on my serial port. So this serial 2 here saying if I receive any data, just chuck it down on the display so I can see it. So now I'm going to go to Tools, COM ports, and we're going to select COM15 like we have on the device manager. And then I'm going to say Tools and then Serial Monitor. You can see that there, it's coming up nicely. So you got the serial monitor down there. I just wanted to make a simple code. Let's just do a code now, just a second. So what I'll do, I'll just write it down now to make it simple, because it looks like that's an old code and I've had some stuff in there. So let's say serial.begin 115200. That's the baud rate in here. And then serial.println starting serial. And then in here on the loop, I want to do really simple stuff. So serial.println, let's just say dot, right? Nothing really special. And then delay 1 second, and that's pretty much it, really. It's not rocket science. And so save that, and I'm just going to call it serial test pings. That's it. I'd close that one, not interested. Close it, go on. Oh wait, yeah. Ah! Oh my god, come on, really? Why did you close all windows? Okay, so now we're going to deploy that. Should become 15, it should just work. As you can see, really simple code. No rocket science. It's just basically saying, put a dot and then delay for 1000. Just to see if we have a heartbeat for the ESP32. There we go. Yep. Now it's writing the stuff. What's happening there? Let's see. Wrote, compressed, wrote that stuff. So it looks like it wrote them down. The fatal packet transfer stopped, received 15 bytes. Let's try to reset that. Let's just go to Tools, Serial Monitor. And this is COM15. So if I just restart it and restart that again, and I think if I just restart it like this and now deploy, upload. There we go. So now we have a heartbeat. So now we know the serial port works fine. I think the reason it didn't work before because I had something underneath it. Duh. Anyway, let's just put this down there just in case. Excellent. Okay, good. So now we have a working board. So this is now a working ESP32, and you can see that now. So if I restart it, reset it now, just click that, it will reset nicely, and then as it comes up, it'll keep pinging. So clear the output now, there, and there we go. So close that and reconnect the serial monitor. I should see the dots in there. Perfect. There we go. Starting serial, and yeah. So just change that to print instead, not println. And there we go. Try that again. Clear the output. Anyway, so we know the ESP now works fine on that board, so, which is great. Now that's one serial port working fine, and now we have the second serial, which I kind of had a look at it and understand now why it didn't work. We'll get down that way. It was a little slow to compile because, yeah, now it's uploading fine. Good, there we go. So now we're displaying it like this. Perfect. So now we know the ESP works absolutely fine. There's nothing wrong with it. You know, that ESP is fine. What's not working on the ESP is the debug port, which is the JTAG. So if I disconnect, reconnect it in here, and I try to access where's that, waiting for that port. There's no port coming up, so that means there's something not right on the JTAG. Now, looking into the design, if I go to my design, I look into here, and I had a look earlier on. I managed to figure out what the problem is, and what I've done, I've measured the voltages. It looks like there's a leakage on that side between the V-bus pin that goes into ground. So it's actually leaking to ground quite significantly, and it's not outputting the 3.3 volts over here. So we're not really reading that well. So that's the problem. The issue I discovered is actually, rather than putting 47.5k resistor in here, I had 4.75 instead. So that board now has the wrong resistor, so we're going to now replace it. So C181 is what, sorry, the R117 is what we're looking for, so take that off. So this is the first thing we're going to fix now, the R117. So we need the microscope. Okay, and now let's change the display to read the microscope. Yeah, so we should be good to go soon. Yeah, that should be the good display. Perfect. Okay, so now what we're looking for is the R11, let's just double check, 117, isn't it? 117, yes. So R117 lives on here, there it is. See that? I pointed out on the tweezers, that's R117 here. So let's just get the focus, actually focus is wrong there. That's better. There we go. So R117 is here. We need that off, and we need to replace it with a 47.5 instead, not 4.75. So first things first, let's just power up my tweezers basically here. So just move it out of the way. Yep. And 4.75. Let's get a 4.75 in here. So let's see, what do we have? 4.7k, that's one. Well, we need 4.7, let's go. That's a 4.75k one, there we go. So that's the resistor we need. We just need one of them to replace that. So first things first, let's take this one off. And I need you at 400, it's easier. It looks fine. So first we'll need to take that resistor off, the 117. We need to put some solder in there. There, like that. And here is fine already. Yeah, that should come off nicely. Yeah, came up nicely as we wanted. So now that 4.75 is out, take you off. We don't need you there anymore. That's off. And I want that one here. Yeah. And now what we're going to do it's a bit of a cleanup there. Yeah, I'll just clean it out first. And that looks good now. Yeah, that's good. So now we'll get the 4.75 resistor. One of those. You can see I prepared so many tapes for the pick and place machine. Just had no time literally to come and install them yet. I will do, I promise. It's just really busy right now. So I need just one. I just need one out. Getting close. There we go, found it. Just one. That's it. Here we go, got it. Perfect. Anyway, that's right. Okay, so got one out. Exactly what I'm looking for. Back into the bag. Good, and now we'll have that one here. So that goes, I'm just going to turn that board. Yikes. Did I? Oh my god. There it is, yes, thank you. So there we are. That's where I want it to be. Yep. Just put it upside down. Actually, I don't like it like this. Something isn't right. Let's clean it off. All that flux, I need that. I need it out. Yeah. Good. Now, let's bring you back in. like that. There we go. Now let's start putting it in. I don't know if you can see it. You should be able to, yeah. And it looks good now. Yeah, I like that. Now let's add a little bit of support on the other side. And that's exactly what I want it to be. Good, that looks fine. Now let's turn it down, see that side. Very nice. So there we go. Now we have a 4.75 resistor in that place. So take it down. And now we are looking into this. So we have a 4.75 resistor. I need to clean that off. So that's the first bug. Let's check now. So turn it upside down and then monitor again. So then the microscope goes away a little bit and then now back into the screen. There we go. And now let's test again. So the last port in the past was not giving us any outputs. Let's just connect it now again. There we go. Hear that sound? Beautiful. So now we have COM16 coming up, which is perfect. If I can find my mouse, there we go. So CP210X, which is perfect. That's exactly what we have on that screen. So that's brilliant. Now we're going to connect to COM16. So we'll just do a duplicate of that. Copy, paste to COM16. So we'll just call this a COM16 and COM16 here. There we go. Okay, and now we'll okay that. So just this work on COM16. Look at that. Beautiful. See that? Now we have a JTAG. Let's just take it down. Too big of a screen there. Yeah. Okay. So there we go. Now we have the ESP COM blah 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 coming up, which means the JTAG port for the ESP is now working up and running. So that's the first bug I've fixed, and now we carry on fixing. So we know the ESP and the debug port works fine. The reason I have these two ports in here is because the future design that helps me on the Omap side, I no longer gonna have to rely on an emulator and connect it to CCS. So my plan is, obviously it's not happened yet, but this is the emulator in here we're talking about. This is the XDX100. You have to buy that separately to use it with an Omap or most of the Texas Instrument systems or chipsets. That is a JTAG port in here. You connect that down, and then that's how you flash the stuff, or you debug the stuff from using that little device. That's not included with the Omap board, and it's a different thing. So what we're gonna have to do, or eventually what's gonna happen is we're gonna have these pins mapped up to whatever pins we need them in here on the JTAG itself, and they will act as an ESP2 Omap flasher or loader, whatever you want to call it. So that's where I'm going at with this, and it's going to be mostly ESP32 and debugging the ESP itself, built it on the motherboard. So that bit now looking okay. And the other side now is, I wish my wife could stop printing when I'm making videos. Anyway, right, okay, sorry. So coming back to the reality. So now we have all ports are now working fine. Now going back to work on the Omap Direct here. So I'm going to disconnect. So just disconnect here first. I'm using, in case you wanted, a product called Secure CRT, which I really like. I'm licensed for that. So now disconnect that one here, and now I'm going to connect it back to the UART2 of the serial port. So this is the chip in here to power up to access the Omap, or to talk to UART2 on the Omap side. Now for that we have to kind of tell or change the dip switches on the system to tell it to start powering up or booting up from the UART2 board. And to do that, on my main system, or the main design for the Omap in here, you'll see I've got the circuitry for the booting section is this. So now there's 8 pins, or 8 boot pins, 0 to 7, boot 0 to boot 7. And if you are designing an Omap circuit, you're going to have to make sure that you get this bit right. So how it works is we have a pull-up resistor and a pull-down resistor. So in here what we have is the boot mode. If the switch is open, your Omap pin will be pulled to ground by the 1K resistor. But when you connect it, when you put it to on, you're pushing down a 3V3, so 3.3 volts come down to here, goes to the pin itself. So what that means is via the 5.6K resistor, we're pushing 3.3 volts to go to the Omap pin. Yes, I know when you do that and you have that 1K going back to ground, you are leaking a little bit of current, but that's a very negligible current. It's not an awful lot. So it basically means in either state, on or off of the pin, we are saying if it's off, connect to ground. If it's on, connect to the 3.3 volts. Obviously we can have a dip switch, or we can have a setting. So that's where it comes from. So now to get this done in here, so as you can see, I'm doing 1, 2, 3, 4. There's a 0 to 7, as I said earlier on. The 0 and 7, the 0, 5, 6, and 7. Looking at the schematic, I don't really care about the 0, 5, 6, and 7, these pins, because if you look at how the chip works, on B0 is always 0, because see that here, if it's 1, I don't want to boot from I2C slave 0 or SPI 1 or UART1. So I can live without those three, those 1, 2, 3, 4, 5 devices. If it's 0, which always is, that pin 0 in here, this one, is always going to be 0 and always allow that bigger section to load up. So I want to choose between 9.8, 9.16, UART2. UART0 may or may not, but UART2, NAND 8 is what I'm actually targeting at the moment. And that's the list, that's a good list. Now, this is all zeros, as you can see, pin 0 is all 0 always. And the rest, which got those 4, 1, 2, 3, 4 switches, are 1, 2, and 3, and 4. So to power up on UART2, we need 1, 0, 1, 0 on the system. So that means that's SW8 should be 1, 0, 1, 0, right? And this is where we're going to come to the second problem of the system. So let's look into that now. I'm going to take you back to the board. Let's do a bench full screen. There we go. So now you can see it there. And on here, the SW8 is that one. So we're going to power off the board and change. What we need to do is UART2. So it's 0, 1, 0, 1. So to do 0, we have to leave that switch open. So that should be open, and that is now open like that. I'm pretty sure that is the open, and I do that one here. So and then like that. So that's how the switch should be. And I'm just gonna make it a little bit more easier to see. So you can see now the switch SW8 there. You see that where I'm pointing my index finger here. So 1010. I mean, if worst case scenario, if it doesn't work, we'll flip it to 0101. It makes no difference. It's no harm. We just need it to power up on UART2. But now what's going to happen? So now we're going to connect the serial on UART2. So we're going to connect that down. And you can see we got the serial up and running. Just waiting for that to come up. And there we go. That's the USB serial there. COM13. So we're just going to go into the COM devices and then copy that to from COM16. I want to copy that to COM13. So we're going to do COM13 and then COM13 there. So COM13 I'm going to connect, and it's connecting fine. And I'm going to reboot, but watch what happens in our reboots. There. See that? And that's to do with the design I have. That's the bug 2 on the system. What happens in there is, as I'm pressing reset, right? The reset is going to the Omap and telling Omap please reset, but from the Omap is coming out saying reset the rest of the world. And that's my problem, that I included the serials in there as well. So if I wanted to have a signal out on that serial, as I'm resetting the Omap and then resetting the serial instantly, I'm disconnecting it from the PC. So I really don't know if we have a wake up from Omap saying yes I'm here or not, or something else is going on. So we don't know yet. So what we're going to do is take off the FTDI from the serial. Take the reset pin of the serial. But I'm just going to walk you through that now. As I am resetting the system, I'll show you that in English or in more detail. So just to let you know what's happening in here, the reset pin, you see that? The circuit for the reset, as I'm pressing the button there, that's just going to go that, there we go. So that's the button, that's the switch I'm pressing. So that goes into the RST01 chip. And that chip in here is sending a negative reset and goes down to the K14 and into that pin in here. So what happens is a reset is being triggered and asking the Omap to go and reset. But then reset out is where I'm posting it to a reset N. So reset N is where just going to search for reset N, and I'll show you where it's going to. So reset N goes into this one here, T17. This is the source, and now it's going to the header pins, which is the H18, that's fine. That's just the header pin as far as the debug, and it also goes into the DAC, the PCM1793 DVR. So that's the audio chip. That's the audio out. That's what's on the other instruments as well. And it also goes into the AIC 3106, the audio chip as well. This is the equivalent to the EVM board, and it also goes into another chip, which is the 1802. This is the audio input chip, also available on other audio instruments. And then find next, it also goes into the reset in here. And notice I've actually done the fix on these things. So I've fixed this problem by disconnecting it. So I said that reset N, please don't connect it to the reset in here on the schematics, but I didn't fix it on the board itself. So I need to do that now. So disconnecting now, and what we need to do, we need to fix it on the Omap, on the FTDI. So on the FTDI side, I know where the pin is, and I'm just going to straight disconnect it right away, just be on the safe side. Because I've done it on a previous board, I already have where the location is it is for. So anyway, I wanted to touch on that in here just in case. Let's just load up the Omap. Anyway, I mean, I know where the pin is. It's pin 18 on U12 and the pin 18 on the other side as well. So we can, you know, we can kind of dive into that. It is a square chip, but you know. Right, okay, let's just go into it now. It's taking too long because the system is kind of doing lots of stuff in the background anyway. So you're going to do the microscope. And I'm going to look into that here. So back into the microscope view. Yeah, there we go. Okay. So now you see those two chips in here. As I said, I know where it is. So you got the first FTDI chip is this one down the bottom there. So I'll point it out. So that's here. So we're going to count pin 18. So we'll do, as I say, 1, 2, 3, 4, 5, 6, 7, 8, 16. So hold on. No, sorry. That's pin 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18. There we go. This is pin 18 here, the second one. That's correct. Right? So what we need to do, you see that here coming out. This is where the reset pin is going. And can't believe the system is not switched to the other schematic yet. But I can tell you for now what's happening in the back. So I'm just going to zoom onto it now. And I want to show you that here. So you see that pin in here, this one. That's the reset pin, goes into there, to the back of it. And when you click reset, this will kind of tell it to reset now. So I just need to cut that connection down off down here. I'll do that right away. So if I zoom out, move the chip this side, because I don't want that reset to kind of, you know, cripple my work. So all I'm going to do is going to get a sharp knife there. And you can see that there, so I'm just going to cut that pin like this. Just hold it with my index finger as well, like that, just to very accurately hold it from here, and there we go, almost. There we go, so that pin is now cut. And now let's just clean it off. Okay. And now let's zoom onto it just to see on the safe side. So as we zoom on now, you see that now? Do you see it? It is completely being cut in half. Yep. And now what we'll do, we need to cover that off. Yeah, and don't worry about the thing next to it, because these are not pins. The pin is literally what we cut only. There's nothing else being cut or needs cutting. So that is all good. I just want to make sure that we take these off. There. Perfect. And now we have that kind of completely cut off. Perfect. So that's the pin goes here. That's the pin we need. That's not off. And now we need to kind of apply some mask on that. So we're going to apply mask on this one. And I've got a little bit of mask in here. And I need a little bit of a... Actually, let me show you what's happening on that side. So I'm going to put the mask in here so you can see what's happening. So mask goes here a little bit, not too much. That's enough. See, just a little drip. And I need a little bit from there. And now I have the mask on my tweezers. You see it? And I will do That's a lot. And now we'll wipe the excess off. Just need some Kleenex. Yeah, that's good. So now we'll just take you down here. So that looks fine, but I need to make sure that it's actually, you know, clean enough. Yeah, that looks fine. Where are we? Yeah, there we go. Yeah, you see that? There's a little bit there. I just need to move slightly off. So, yeah. So that mask looks good. Nice and clean. Yeah, that looks perfectly fine now. Aligned and in place. Now I can just wipe the excess off. There. So that's good now. Now what we're going to do is kind of straighten that up. And as it is now, that looks fine. I could add a little bit more, but I don't really think I should. I'm just going to touch a little bit more on that. And I could. Just a little bit like this. Yeah, I think that's fine. Yeah, so I'm happy with that. And now what we'll do is get UV light to kind of strengthen it. Shouldn't take long, a couple of seconds, well, 10 seconds I would say. Yeah, I think that's fine. Let's check. Yeah, that looks good, solid, perfect. That's it. We're good. Now, let's start testing again. So now when we reset this time, we should be feeling better. So now what we'll do is connect the USB again. So USB 1 going in. Good, we got the COM ports back. Let's just go back to full screen. And sorry, to screen capture. There. Okay. So now it's loading up the devices. So COM13 again, and if I stop that and then launch it again, COM13, yes. Now it's connected. So if I hit reset, right, it's no longer restarting the serial port, which is brilliant. That means my switches now are the opposite way. So if I just do that, put 1, 2, 2, 3, and then 4, and then disconnect, and then reconnect, and then disconnect in here one more time, reconnect one more time. Good, now we're here. So we connected, and if I reset, there we go. See that? Beautiful. So now, when I press reset on the Omap, I get boot me. That's not bite me, it's boot me. Now, this is good. It means that we have a progress. That means the chip now is talking to the serial, and the serial now telling us I need booting. And this is where we kind of end up on that section. So boot me is where it's basically waiting for us to boot from UART port, and now it means I'm gonna have to push down the code from the serial connection to tell it to go and boot up. And if I stop this now here, so I'm going to stop that connection, I'm going to go to command prompt and then say I want to load up on COM13 there, right? And I'm going to erase the chips now. So if I go like this and waiting, and if I click that reset in here, look what happens. So now it's doing some stuff and it's waiting for SFT, and now it is kind of did the stuff. So just to touch on what's happening in here, it received the boot me there, which is brilliant, and now it's starting the sync and now processing command number 1 and doing an opcode sync in here, and then afterwards it's loading up the code into section into 8000 well the higher end of 8000, so 8000,000, and then it's doing a loading up the rest of the code and then doing a jump to that address. So it loads the code up in here, and then fire goes run it from that address in here. Pretty nice, pretty decent, but you can see nothing is happening. The SFT code isn't running because there's a lot of things in the back. Now, the problem with this, well, let's just look at the bright side first. The bright side is now the Omap is talking to us. Now the Omap is kind of doing stuff, but we're not there yet. We just can't tell it to go and flash the stuff up. Why? Because it doesn't yet know what memory chip it has, or what flash memory it has, or what kind of clock that chip operates on. So all that kind of stuff is still yet to be kind of worked out. We have to tell the chip how or where what things connected to it, and then we can move on from there. So I don't want to go into this video about completing that side, because that's another topic that will require a lot of work to actually come across. So just to keep the video simple, let's just call this a part 1 of the work for the Omap side. I will carry on, with more videos coming up, but I think if I wanted to add another stuff to this video, I would suggest, or I would go back into working on the other side, especially the audio and things. So, to be honest, let's just keep things simple. So let's just call this part 1 of the video, and let's carry on in another part of how we're going to continue diagnosing the other stuff. Because eventually, or later on, we want this Omap to work. We want this to kind of see. But you can see now with the screen, we have a heartbeat, we have a pulse. But that's all we have. We just have no brain. We have no memory. We go all over the place, a complete mess right now. But it's a really the light at the end of the tunnel. So that's all I can say. So again, I wanted to wish you a Happy New Year. and thank you very much for your subscriptions, for watching my videos and your interest. I will add more stuff as I'm going along. What else I needed to say? Yeah, I mean, to be honest with you, it's really grateful that now the channel has nearly 800 users subscribed to it, and it just means a lot to me that just to see you all, you know, kind of interested in what I do. And the journey isn't really about getting many customers in there. I could have done a food channel instead if otherwise, but it is a it is a kind of a tailored, dedicated stuff that what's in my head. And I said it before, could be, you know, from frying an egg or doing complex rocket science stuff. So thanks for watching, thanks for your support, and really thank you for everything that you said, and hopefully we'll carry on and we'll do more videos as we come along. So thanks again and have a lovely time. See you, Happy New Year.